Now we will look at some of the material that could be used as cables for carrying optical signals. The two material that could be used are number 1, plastic, number 2, silicon or glass fiber. In the case of plastic, the cost of the cables are not high. However, the speed and the distance to which the information could be carried by optical signals is lower as well. In the case of glass fibers, we could have higher speed transmission, again depending on the mode of transmission that is being used. The purer the glass fiber, the better the transmission characteristics. So, if we were to implement single mode fiber optics transmission, then we need to have a glass fiber that is very pure. The purer fibers are obviously costlier than the not so pure fibers. Also, we need more hardware and more sophisticated hardware to implement single mode transmission along a pure fiber. Here is an example showing the method of transmission in glass fibers. This particular example was obtained from a tutorial posted on the Corning website. The light rays in this case are reflected and transmitted along the path of the fiber. It is made possible by the fact that the core glass has a different refraction from the cladding. As such, the light rays reflect at the boundary and travel along the path of the fiber. Here is another example showing the transmission of the light rays. In this case, as we learned earlier, the mode of transmission is multi-mode. Here are some examples on the size of the core and size of the cladding. In one case it is 62.5 micrometers and in the other case it is 50 micrometers. Also, in this example, it is stated that multi-mode fibers are typically used in private premises of networks where signals are transmitted in less than 2 kilometers length. In other words, if the transmission is within 2 kilometers, then one would use the multi-mode form of transmission. Here is an example that shows the single mode type of transmission in the case of optical transmission. This, as we learned earlier, is more sophisticated and more advanced compared to the multi-mode transmission mode. It may also be noted that for single mode transmission, the fiber cables that are used will have smaller cores compared to multi-mode fibers. The single mode type of transmission is used primarily for telephony and cable television applications. It is also used for campus backbones, which indicates that single mode transmission can travel further, and it is used in larger networks as well. Here are some examples that show different types of fiber connections. In the first case, the illustration shows a type of connection that is known as the SC connector. In the second case, a connection that is known or connector that is known as the ST connector is shown. The ST connection is used where high performance is required. One may note that in the case of fibers, there are always two connections per line. One is used for sending the information and the other one is used for receiving the information. The two connectors that were shown are necessary because of the fact that light rays cannot be sent along a single cable in both directions at the same time. This, of course, is not the case with electronic signals. By using different frequencies like frequency 1 and frequency 2, we could transmit information along a single cable in both directions. Let us now look at a typical fiber optic connection. For example, the connection is made as follows. On the origin, we will have two connectors that will connect the origin with its destination. We have already seen that fiber optic cables have two connectors. One of these connectors is termed as TX, that denotes transmission, and the other connector is termed as RX, that denotes receiving. On the other side, this is the sending side, and on the other side we receive the signals. In this case, RX is connected to the TX port on the other side. Likewise, the TX port on the sending side is connected to the RX port on the other side. Whenever information is transmitted from point A to point B, it will travel along this path. Whenever information is transmitted from point B to point A, it will travel along this path. This is the reason that we have two connectors in the case of fiber cables.